I'm going to kickstart the panel with a few questions, but at any point in time, if you are in the audience and you want to ask a question, raise your hands. I'll see you, and then we'll get the mic to you. Now, some of us you already seen. I've introduced myself. Edward has introduced himself. So I'll now pass the mic again to Nodar to introduce himself, and then we go right.
Yeah, sounds good. I'll do one once more for maybe people who join later. My name is Nodar. I'm co-founder, CEO at Shuttle. Originally from Georgia. I came here to the UK when I was 16 to live by myself, to study. Actually on Friday becoming British as well, so big. Yeah, long time coming. So my story is just before starting Shuttle, I was working in a quant hedge fund, and we were trading behavioral strategies, and we were obviously using a lot of Java and Python there. It was fun, and in 2019 decided to start a company, and 2020 got into Y Combinator. That sort of changed our trajectory quite strongly, and Shuttle probably beginning of 2022. That's when we started working on Shuttle. Our users brought us to the idea of working on backend development. And since then, I've been quite enjoying building the product and the team. It's been quite a fun ride. I'm here to probably provide more, like we have very talented people here to provide more technical perspective. I want to bring in my point of view, which is more the business founder side and what it is to deal with Rust, when you're building a startup. So that's me. Over to you.
Thanks, Nodar. Hi, everyone. I'm David. I originally started out in physics and then worked my way into scientific software, working at various places like the Diamond Light Source and the Wellcome Trust. And then I moved to the West Country, where I still live, and worked with various large government organizations. I sort of moved from building to designing apps. So, we worked in a big organization. They had a big engineering department, and that wasn't really producing the sort of work that the people who worked there needed, right? The business needed. So we had this innovation team that was there to really sort of sit amongst all the analysts and all the business and do work for free and build stuff that they needed. And we had a few great products, and I really enjoyed that sort of finding that fit and really understanding what it is that customers need. I've always sort of enjoyed that sort of dynamic, sort of startup-y life. And it was kind of like entrepreneur. Sorry, I'm used to using a microphone. It's kind of like being an entrepreneur inside a company. And then I've known Matthew, my CEO, who's sitting over there. Hi, Matthew. I've known him for years. Our wives are best friends from university, and he came and suggested we form a startup. He's got a background in sales and cloud services and growing businesses and scaling businesses. And I thought that would work really well with where I come from, which is sort of innovation and creating products and trying to find product market fit, and I could kind of build things as well. So we founded Arwen.ai, and 3 years ago, and it's been a really exciting journey with lots of ups and downs. And I'm the CTO, and we've started thinking about Rust, which I think we'll go into a little later. But yeah, it's been a great journey. Startups are pretty wild fun. Oh yeah, so Arwen, yeah, thank you, Nodar. Arwen invited us here. Nodar invited us here. Sorry? What do we do? Sorry, that's the marketing talking. Arwen.ai protects sort of social media accounts from unwanted content, protects audience, brands, and the staff that work with social media content. So we social media sort of services. So we work with big companies like Mercedes Formula One, ITV. We protect all the channels for all their shows. Stuff comes in. We collect a lot of content from Facebook, TikTok, Instagram, all of those services. We classify it using machine learning. Some we buy in, some we build in-house. And then we moderate based on what that customer likes and doesn't like, right? So football teams don't mind a bit of swearing. They're kind of well known for it. But daytime TV, it's a no-no. So, that sort of content gets removed from their channels very quickly. It improves we think it improves engagement, conversation, it reduces hate speech on those channels. So yeah, that's what Arwen does, and we've got a bit of investment, and we're on the road to profitability. We've got a good sales team, and we're getting some traction. So it's been really exciting.
Nice.
Thanks.
So let's get a little bit to know you better, right? This was about who you are. I like to start these panels, since this is a Rust meetup in the end. What was your journey into Rust? And I think let's start from Arwen, because obviously you are using Rust in the product, which is a slightly different perspective from Shuttle, who's, I wouldn't say selling Rust, that probably is the wrong angle, but it's a platform that tries to sell to Rust developers. So you're looking at it from a slightly different perspective. So let's start from David, perhaps.
The way we wanted to build a startup, and I think a good way of building a startup is to build extremely rapidly, cutting a lot of corners to find product market fit, right? There's no point in building a cathedral and then no one's religious, right? That's like, that's a bad analogy, but you've got to find a fit first. So we built extremely rapidly with tools we needed, we knew, and now we've come to a point where we sort of recognize what we do need to really have a very stable architecture. We need to redesign some things, we need to do some rewriting, and we need to consider an alternative to the TypeScript code base that we have. We have had quite a few problems with that. So, what drew us to Rust? How did we start this personally? My brother, who was supposed to be sitting where I am, but he's unwell, unfortunately, at home in bed. He wrote a little tool called LK, and it's just basically like a command palette for all the bash scripts in your project. And we have a lot of bash scripts, a lot of configuration. It's part of some of the technical debt that we've got. And LK is sort of like, it's called LK because if you flap your hand on the keyboard, you kind of hit LK, right? So it's supposed to be very rapid execution of your project's commands. So we built that, and it was fantastic. It worked really well. We use it every day. Look it up on GitHub. And and then we wrote some other command line utilities in it, and I did Rustlings, and the rest of the team did Rustlings, and we talked about it, and we did merge requests on James's code, and we started writing some real production services in it, and had a great experience. So.
Cool. I mean, my story probably started back in that hedge fund. The first person to introduce me to Rust and my other co-founders as well was Damien, our CTO at the time. So his main argument for Rust was a bunch of much smarter people came together and engineered a compiler that's going to prevent me from making stupid mistakes. And he was quite excited about the overall developer experience and was kind of raving a lot about it. And as I mentioned, we were, in that hedge fund, there was a lot of Java and Python. Things would often break in production. So caused a lot of uproar, and when you need to trade and your model is not giving you signals for some reason, or your trading platform is Borg, it's pretty stressful and stressful times, I would say. And so that idea of or that promise of better developer experience and ultimately more reliable software was pretty appealing at that time. Now, of course, when you're starting a company as well, and I don't know if we want to touch on that later more, but when you're starting a company, it's much more pragmatic than normally, right? Than this, and we needed to build, let's say, reliable software, and so it made sense to choose Rust. But I think in our case there was a little bit of whoever's leading the technical, whoever's the most technical person, he ends up choosing the stack. and there's a bit of that. There's obviously people can challenge sometimes, but at that time it was quite a light discussion. We didn't even have a discussion. It was like, okay, we're doing this in Rust, and it ended up taking us down beautiful path that now looking back, I can connect a lot of dots and see why it was an amazing decision. And actually, us sitting here right now is because of that. But it was kind of almost a non-decision at the time. It's
It
just
happens very often, right? Like you go to a startup and you ask, why are you using technology, right? Can be Scala, can be Haskell, and the answer is, well, the first engineer was a good Haskell engineer. And it kind of like snowballs from there. And snowballs probably is the negative view, but can bloom or sink.
It's in this changes enthusiasm that got was infectious, and we were starting to sort of get interested in it. So,
Gotcha. So you mentioned before, Nodar, I think that's interesting, that obviously building with trust, there's a perceived feeling in most cases that you're getting something that is more stable. Or to say it differently, that you're doing more work up front, making sure that it's right, instead of doing work after the fact, debugging it so that it becomes right. But there's also trade-offs compared to other ecosystems. Like if you take Rust and you compare it to Python or you compare it to JavaScript, you're comparing ecosystems of different orders of magnitude in terms of developers available, libraries available, age of the tooling, which has positive and negative connotations. So how do you balance the speed that you get from a larger ecosystem, where very often you can go on npm, this module, this module, this module, this module, little bit of glue. I mean, might not be beautiful, but it works. And instead, the Rust ecosystem, where it's a little bit smaller, perhaps, and sometimes you might have to write stuff yourself. For example, how often does that happen? And we can start probably from Edward.
Okay, I would say, looking at the way Vortexa is doing things, because of course it's a startup. I mean, we kind of grew from nothing, and just the point that you just made, that we started using Python because we hired a data scientist, and data scientists do Python. We started doing Java because I had a background in investment banking. They hired me, and that's the hammer I was holding. So a lot of this was just sort of ancient history, how it came to happen. But now we're more established. We've got a code base, and we're trying to refine things. We're still trying to move fast. It's a scale up. There's still lots of work to do. It depends on the problem domain, and I think we have several. We have a data science problem domain where still Python is king. We need to keep the data science developers working rapidly, and it's not, these are not software engineers, and it's not realistic that they're going to be doing Rust, to be honest. There's another domain as well where we have reasonably low latency, and I would say we haven't cracked the solution of streaming data using Rust. There are streaming frameworks out there, but they're not comparable today with the streaming frameworks that we're finding, for example, with like Kafka streams on the JVM platform. So there are some constraints where Rust doesn't today feel like the right tool. There are other things where you saw in my presentation where we can make surgical changes and make a massive difference. So we do run into issues where I would say that you feel that the ecosystem is small, where, the classic one is like reading a Parquet file. You do that in Python in one line of code. There are libraries to do this in Rust, but it's not as mature. So it is something we're running into, but it keeps improving.
I guess from my side, there's definitely a big change that we've seen, like starting in 2019 to now. The scale of the problem has changed, and that's probably one of the things that's giving a lot of hope, right? So things are improving in terms of the ecosystem like maturity, readiness, if you want. We still do run into problems. I mean, the one that we have right now is there is some feature of Datadog that we would like to use, and we're using also tracing framework, and they don't play nicely, and there's a certain feature that we were not able to use because of this, which is probably a problem that's solved well in other ecosystems or has been looked at already, but it's just something that we need to, let's say, invest more time into and try and find workaround, so to speak. I would say that this is more like feeling. I don't have hard data to say, but feeling based, it's getting better. And
well, you touched on an important point, right? Because when you look at an ecosystem, there's the size of the ecosystem, as in the ecosystem built by people working with the language, and then there's also the investments that companies are putting into certain ecosystems. Like Datadog probably has an extremely polished Java SDK. I haven't used it, but I'm willing to bet a lot of money on that because they see that as a big market. Then if you look at Rust, you get AWS as a nice Rust SDK. Does GCP have a nice Rust SDK? No, they don't. It's not even first party. So that is an issue which I think comes up quite often when talking to people. Like, you are not going to find ready-made company-maintained like SDKs for services. Like, very often you find volunteer-maintained, variable quality, good or bad. Anyway, David, sorry, I cut you off.
Yeah, that's exactly our experience. We integrate with a dozen or so external systems. So one of the great things about Rust is how its correctness and its modeling it makes it very easy to be very precise about integrations. When you have lots of integrations like that, I'm sure you know, it can cause a lot of bugs in production when people, tracking down how APIs change and that sort of thing. So most of those external systems do not have Rust libraries, but a lot of them have Twitter libraries or, JavaScript libraries or TypeScript libraries or Python libraries. So we're having to do quite a lot of work there, really. It is very nice to have now in production AWS SDK. that's very useful, and we make use of that a lot. So yeah, it's in some ways writing all this stuff yourself. We only need to use a few key parts of these APIs, and having a deep understanding of exactly how they work and defining that ourselves, and having that control over those is not necessarily a bad thing. We're not trying to get up and running really quickly anymore. We're trying to build a very stable system. So building it ourselves and understanding it deeply is fine. It's reasonable.
It'd be nice to have the option, I guess, right?
It would be good to have the option. But, I had that option with Twitter. I used a library, it was V1, and I wanted to use V2, and they didn't support it and they didn't update it. So I had to get another library and do another library assessment. So, even if there are libraries there, they're not necessarily good libraries.
Yeah, I mean, that's the other thing about third-party code. Like, you need to check it.
Exactly, yeah.
Takes time on its own. I think this is a nice segue into, I guess, the following question, which is still a little bit negative looking, but I think it's important. I was speaking before with a few people in the audience, and there's a lot of Rust flag waving when you go to Rust events, right? Rust is amazing, does all these right things, which I think is good. At the same time, though, you want to give a balanced view. Like, you want people to see the good and the bad, because in that way they can make somewhat reasoned, informed decisions. So the question I have is, what do you think is the top challenge you have with Rust and Rust in general? Like, what do you see as the main problem or the main thing that needs to be solved or improved going forward?
I mean, it's probably recruitment. There's a lot of people who probably want to work in Rust. There's a hell of a lot of TypeScript engineers out there, and they're pretty cheap. I mean, to be absolutely honest with you, it's hard. There are fewer Rust engineers, and they're very expensive. Personally, as an engineer as well as a CTO, compile times are a pain. I've got a MacBook Pro just pre M1, and it's pretty slow. It's like that dev cycle that you mentioned a number of times is just a bit too frustrating. That's a minor thing, but I'm sure we've all come across that.
Yes.
Yep. From my side, a few points probably. I mean, again, this is like a startup perspective, so take with a grain of salt. But iteration speed is probably not the strongest suit of Rust. You build code that's probably going to be better quality in most cases, or at least you will need to do a bit of work to appease the compiler. But once it's done, what it sort of leads you to as well, and that's kind of the other side of the coin, is that you end up with generally better code that's more maintainable. And so when you're prototyping and doing those iterations, what happens quite often, you're trying to move fast and break things, right? And you have some sloppy code, and that happens. I mean, that happens in Rust as well, as you rightly pointed out, Luca. But the magnitude is different probably with Rust. The other thing that we've noticed on the hiring front is I think that's probably to the point about Rust engineers being in high demand. At some point, there was a lot of crypto startups looking for Rust engineers, and that was also driving the salaries up quite a lot. Nothing against crypto startups, but that made it even more.
Nothing against the salaries.
Also nothing against that too. And then on the other hand, hiring, and maybe worth touching more deeply onto hiring. But what I find is that generally you, for some reason, the quality of let's say applications tends to be higher. So what we see is that whilst there's less people maybe than in other ecosystems, generally people are already quite well versed, and that's pretty good. Even if they don't have a lot of production Rust experience, seem to be high quality candidates who you have more confidence in sort of like coaching and bringing them up to speed. That's what we've seen. Like it's sort of, there's a little bit of a filtering already done for you, but it does mean that you're selecting from a smaller pool of candidates, and that's a challenge.
Called the Python effect, from an old article from like Paul Graham. I think we're talking early 2000s, where he was basically describing exactly the same effect for hiring Python engineers back in the day when Python wasn't that hip. Because if you are following the recent trends in technology, that already puts you into a smaller pool of engineering talent, and that means that people coming out of the pool generally are more prepared. So it's not necessarily about the technology, it's about what that signifies in the interest of that person.
I would agree with that. We interviewed 2 Rust engineers last year, contractors, and I would have hired both of them. The one we did get to join us, who's in Kyiv, he's very good and he's doing really well. At the stand-up this morning, he said there was a missile attack last night in Kyiv. So that was a very sober stand-up. And I have to say, Jira didn't seem quite so important after that. But it's we've spoken to 2 people, interviewed 2 people, both good candidates.
I think it's interesting the comment you made about moving fast and breaking stuff, because of course that's what you do when you're a startup and you're beginning. We're now a scale up and we're still moving fast and we're still breaking stuff, probably too much stuff. And I actually am beginning to think that I do agree with the point that, in a sense, because how stringent working with Rust is, not the compile times, because I do have an M1, but working with Rust can slow things down on the initial delivery. I actually think it's really worth the dividends of not having to go back and do as much maintenance. So I actually think one of the problems for me I see with Rust is actually the perception, because in our business we're continually working on 101 different tasks, different things, different projects, fix this, build that, new feature, etc., etc. And the question is Rust a suitable technology for this? And I like to flip it on the head and think, why isn't it? And sometimes the answer is it isn't. If we were talking about the ecosystem earlier, and it could be that a particular problem being solved, there isn't sufficient library support. Streaming will be a good example of that. But quite often, I think, because of these, you pay up front and then you get the dividends downstream, we need to start thinking a little bit longer term. And I think, getting that maintenance benefit in there really does pay dividends.
Can I say something about refactoring? We have product market fit, but we're still developing and changing things. We're still breaking stuff, and Rust is very good to refactor. It's very reliable to make changes. There are some areas of our TypeScript code base which we don't want to touch, we don't want to change, but the same is not true of any part of our Rust. We happily refactor it all. So I think that's a big benefit.
Yeah, that is true. And I wanted to get back to something Edward said. There's a reputation problem, which is very akin to momentum, if that makes sense. Like, feels like having momentum. It just kind of becomes a self-fulfilling prophecy, right? Like, this framework is getting popular, and then everybody convinces themselves that it's getting popular, and then it gets popular. And this is, in a negative way, something that happens with Rust when it comes to the perceived difficulty or the perceived learning curve. Like, if everybody starts saying, Rust is difficult, but then kind of becomes the truth. That becomes a factoid. Like, Rust is difficult, and then becomes the way you grab the conversation. The reality is that the fact that Rust is difficult is, to an extent, an historical fact. Like, it's what you would have, like, if you tried to learn Rust 7 years ago, before the non-lexical lifetimes were introduced, then you would truly understand what it means to find the border checker. It's like on a completely different level of annoyance, like user unfriendliness and just terrible error messages. Like there's a gulf between what Rust was 7 years ago and is today. But that reputation, like, that refrain that it is a difficult language with a steep learning curve stays. Even if there is data, like from, for example, Google, who runs a fairly large internal training program, where they say, you know what, we train a few hundreds, thousands people every year, and we are looking at Rust, and people become productive in a month and something, which is perfectly in line with what we know from Java and Go. But still, like, that is not enough to kind of move the public perception a little bit, because that perception has momentum and it's very difficult to stop it, if that makes sense.
But can I just add on that I think some of this perception is actually at the developer level,
Yes.
where they have this hammer, they have this tool they're holding already, which they're very familiar with, and it's the easy path to just continue with what they have. And choosing an alternate technology, trying Rust, is definitely going to be more difficult the first time they do it, and the second time they do it. But like you say, in weeks, a couple of months, they can definitely pick some up and be very productive, I think.
Yeah, it's the difference between saying, which is perfectly reasonable, like, we are very experienced with this piece of technology, it's gonna take us less to do it with what we know, which is the truth. Like, there's no denying that, than to say, this new technology is too difficult. Then you're moving the problem from a fact to a perception, which is a slightly different thing. Anyway, wanted to give a chance to the audience to ask questions if there are any. See one end right there.
I didn't really have a question specifically about what you were talking about. It's more a bit of something about advice. So I'm going to be building a new Intel tool, and I need to pick a front end, back end sort of thing. I was wondering, did you build any of your front ends in like a Rust front end thing, like Leptos or I can't pronounce it. It starts with the D and it's Deoxys or something. Thank you. Have you used any of these ones? And what's your opinion? Like, which one would you say is more mature and therefore worth picking over the other one? Or since it's a relatively small project, it might be fine to use the more newer / experimental one, if you see what I mean. So I was just wanting a bit of advice.
Who wants to take this?
So I've done a lot of React, and that's...
You said that as if I was a bad thing.
Well,
Let me get it out. I've done another React.
For the record, React makes a lot more sense than Angular.
I have also done Angular, and I wholeheartedly agree. I've got an investment in it. So although I consider these things, they all seem quite early stage. I know how to deal with a lot of problems with React, and there's a lot of different ways you can build front ends and lots of different considerations for different types of applications. And I didn't have the confidence that any of these things would be able to help me with all of them. I'm much more interested in using Rust for APIs. We have a GraphQL, a Rust API, and a TypeScript API, and we federated them, and we're slowly switching over from one to the other, which has been quite a good migration path from a TypeScript backend to a Rust backend. And it's just way more stable. It runs on a fraction of the resources. It's been a good decision for us. But no, I don't have any experience with those languages, I'm afraid.
I guess a more general way to answer that question is, if you go for something that is more experimental, there's a much higher chance that you'll have to pick under the hood. And so how comfortable are you to do that? And do you have the time to do that? If the answer to those questions is yes, then you can go into. If you're like, I'm primarily a backend developer and need some front end just to get some stuff done, you're probably much better served picking something that has a gazillion learning resources out there, because you'll just ramp a lot faster.
Maybe just to add to that, like from Shuttle's perspective, right? We sometimes people refer to us as Vercel for the backend, and it's an interesting point. Like we ourselves don't use Rust in the front end that much. It's so our website, for example, is on and the console is on running on Vercel, so Next.js. So nothing against JavaScript in the front end, and I think it's we were actually discussing this earlier with Luca. It's interesting because the the fact that JavaScript has been a standard and has created this amazing ecosystem around itself, because it's the language of the browser, has led to the creation of such amazing developer experience as Vercel provides for the front end. I'm not I'm not an investor or have any interest in them, but it's generally a great product. And so what we are trying to do is create that kind of smooth developer experience in the backend, right? And so, for example, a lot of our templates that we've created, we create this like starter examples, or just like build your API in Rust and then make it play really nicely with your Next.js front end, right? And people love that kind of stuff because it lets them, on the one hand, use stuff that they're used to in the front end that has amazing libraries, has great tools that are already out there, and then in the back end use the latest and the greatest, which is Rust.
Question about, I guess, momentum and the library ecosystem that you spoke about. Possibly a question for Ed. How old is Pathfinder? Do any of you guys have a product or a piece of Rust code that's been around for a long time in production? What's your experience been with whatever library or framework you decided to pick, back in the yonder? And how is that compared to other languages that you've used? Because one thing I've found, having used Rust since slightly before 1.0 and for production code since like 1.10 or so, is a lot of the stuff that we built back then now still can pass perfectly, still works. But the CVEs begin to stack up. And people ask, when are you going to fix that? And you go, oh, I'm just going to bump the dependencies and nothing works anymore. And has that been your experience as well? And are we getting out of the woods with that as stuff gets more traction?
It's a good question. Vortexa is about 8 years old. Pathfinder is at least 6 years old, I would say. I can't remember the precise version. It might be like 108 or something like that when it started. It's the same era. One thing we very recently changed, actually, in this year, we were using Risotto to access Amazon Web Services, and we've now swapped that out for the official SDK. I have noticed in the past, I think there's one period around version 120 or something like that, where there's quite a big wave of breaking change, and we had to do quite a bit of work just once. In general, it's not been too bad. I have got one Rust project which is stuck on 1.7.2 because it won't work on anything newer, and I need to address that. It's not a burning issue, but it is an issue. It does happen.
I'm thinking more about, I think the compiler has been very stable, and certainly in the few cases where it has broken stuff, it's been well advertised that it's going to break stuff. I'm thinking more about, I didn't necessarily want to pick packages apart because, we're obviously very grateful people, but Actix 2, Actix 3, Actix 4, like, if you want security updates, you had to go up, and going up was not simple.
I mean, there's Rob back there. You can complain to him.
Throw objects.
I'm not going to point, but...
I mean, for me, the actual example was like Actix 2 to Actix 3, I think. I can't remember exactly the version, but it was a case of where we basically had to decide either we're never going to touch this again, which we didn't want to do, or we have to do a wholesale upgrade. And that was annoying. And, whether we could get... You look at something like picking a very common example, Spring Boot, which is very widespread. They do like patch updates and security updates for stable library versions for ages. And, are we getting to the point of maturity in the library ecosystem that we could start to not expect, but hope for that?
I think there's three things to consider here. Number one is that Java is more affordances to patch stuff without breaking, which Rust doesn't have. And I say this, and I've seen evil things done to patch things without making breaking changes. There's a lot of evil, devious, but very useful stuff you can do with JVM. Rust being compiled puts you in a much stricter jacket. You can't do as many things. There's also, and I think that touches upon the point you were making in the beginning. Yes, the code still compiles, but it's no longer idiomatic. And I think that goes also on the Actix kind of example, right? What happened between Actix 2 and 3, or between Actix 3 and 4? You got async await stabilizing, And so suddenly what used to be, oh, this is the state of the art of writing a network service in Rust, it's like, this is the clunky old way of doing things. Now we got this much better shiny armor. I mean, yes, I could keep the framework and then version forever and let it become obsolete, or I could write a new version and that's gonna be good. Or you got Tokyo stabilizing to 1.0. It's a breaking change, that's a big wave. Am I gonna be stuck on a version that has no support? Obviously I need to bring forward. Now, some of these things are ecosystem changes, like Tokyo. Some are language changes, right? Like async await, yes, it was a non-breaking change, but suddenly it shifted what was the state of the art of doing things. And this still keeps happening, right? What was it? Rust 175, which came up right before New Year's Eve, shipped async functioning traits. Now, I can guarantee you, I'll make this other prediction, that you'll see another wave of breaking changes, because a bunch of libraries that before had interfaces that were working around the fact that they didn't have async functioning traits will do a new version with async functioning traits. And that will cascade through your dependency tree and you'll need to do a big upgrade. So it is true the compiler has been stable, but in reality, that incremental addition still creates cracks into the ecosystem because you can do things in a better way and people want to do things in a better way. Now, if the size of the ecosystem grows and there's a lot of commercial usage, then you get enough people and funding to do what you're suggesting, right? So yeah, I'm going to release ActX 5, but actually have enough backing to say that ActX 4 is going to be maintained for 3 years. Rob is making signs, I don't know how to interpret this. I think he's saying yes. But it's like you need things to settle to be able to offer the support, and you also need a commercial ecosystem that makes it so that it's viable to provide that support. If you got a random guy in London maintaining a massive ecosystem alone, how much can you do maintaining breaks?
I could add that Pathfinder is based on ActX, so thank you, Rob.
A lot of endorsement.
Absolutely, we did go through that wave of breaking change exactly as you talked about for those reasons. It also uses Tokyo, so we went through that breaking wave of change as well. It's all happened in Pathfinder.
Do they end up patches? I was there. You can
should do. I should get the stickers on the laptop. Yeah, I used ActX one, but it's not been terribly painful. I think the next wave of pain is I know I'm using very out of date Parquet libraries, and they're very breaking changes. So that's going to be quite interesting upgrading that. But I would say this does happen more in the Rust ecosystem than other ecosystems, because the one that I'm used to before is Java, and they tend to do about 18 releases before they consider removing something completely. Their deprecation cycle lasts decades, which has its own set of disadvantages as well. But yeah.
I guess another thing, just to remark on that again, is that this applies beyond Rust, right? Like if you're running any piece of software, the farther away you are from latest, the more problems you're gonna have when you eventually will have to catch up with latest. Like even the technologies that have very long support cycle, they don't have forever support cycles. If you've been stuck on the JVM version 8, eventually you'll have to come on version 11 and then version 17.
Gosh, who would be stuck on JVM version 8?
Not saying anything. There's no shame. You can come out and say, I was in JVM version 8. But there's no delaying forever. Like there's some software maintenance that you gotta bake in. Obviously, the more immature the ecosystem, the more maintenance you're doing because things churn a lot faster. But it's part of like the KTLO, like keeping the lights on of a service, a code base. And obviously, the more code, painful it gets. It was me. Don't worry. Anyway. Any other questions from the audience? Let's get that down there and then we'll go back to him.
Which one?
Not Troy has a beer that's gonna get very ugly.
I'll walk.
Do I like from the bottom to the top?
I don't want no.
Kind of on a similar point, do you think that nightly is maybe a bit too popular? I see a lot of libraries where it's like, oh, to use this, you need nightly version, this and that. Or I think I'm seeing it less these days, but I still see quite a lot of libraries that are like, oh, yeah, you should really use nightly to have a fun time with this. And personal experience recently migrating a old web service of ours I managed to get it up to nightly at some point in May 2022 before we couldn't upgrade it any further because a certain dependency needed a specific feature but was removed the next day. So yeah, do you think the popularity of nightly is a good thing or a bad thing for the Rust ecosystem?
Can we get David's opinion on that?
I stick to production-ready versions of everything, I'm afraid, apart from AWS SDK, which I used for a little time before version 1. So, I mean, I don't really have a view on that, I'm afraid.
Although I think
James probably would.
it's been production ready for long before, it just wasn't stable.
That's what I assumed.
I can tell you that from being on that team. But on nightly, so this actually is very interesting because I think, what was it, a couple of months ago, the team maintaining Crates.io has started to collect version information. So up until now, what version are Rust users using was a very fuzzy question. And there was really no hard data. And that comes a lot in conversations around what minimum Rust version should I support? Like, is it fine to require Rust 174 or should I stick to 163? Should I stick to 140? And it turns out that actually most people are unstable. Like the cowboy days where most of the libraries require nightly seems to be kind of behind us, with the caveat that there are ecosystems that are still bound to use nightly because there are some key features that are not unstable. Linux kernel, one of those examples. Some embedded stuff still requires a lot of stuff that's on nightly. But if you're talking specifically about, backend API development, CLI development, you don't need. You might want to have some fun with nightly, but then, that's a personal choice with consequences. It's not needed.
I think I would second that. I have had fun with nightly. You can quote me on that. But actually using it in production code, no. I was actually more scared than my fellow panelists. I've only started using the AWS SDK when it became stable. We want stable things in production. I think an important thing for me is repeatable builds. I do want to be able to rerun the same code through continuous integration twice and get the same results out, and I get upset when I don't. So I need a stable backing there.
So my question is about cargo and its integration with other build systems. So cargo as a single build system for just Rust projects, great. You've got workspaces, you've got all kinds of nice things you can do. You've got it's perfect. If you are trying to integrate it with other build systems, so you're building a native library that then downstream dependencies want to use, that I have found to not be such a well-supported flow. And I've started looking into, so we've just, for a very long time, about 7 years now, just been using a script where we say, build the Rust project, now build the C++ project. Or C or whatever. And I'm just now looking into alternative build systems like Bazel or Buck to potentially replace Cargo. And I'm curious for if you've looked at kind of polyglot environments where you want to build things with downstream native dependencies, how do you do that? Is it just a series of build this, then this, and this? Or is it something more involved, like one of these advanced build systems?
I think Edward is the best person
to
answer that.
I'd say, so there's two cases that I've certainly got experience with. One is with integrating with Python, one is about integrating with Java. In both cases, it's these other languages that are calling out to Rust. Rust is a library. It's not Rust currently invoking those languages, which you can do. I don't know why you would, but you can. I would say it's a step-by-step build for us. So in the Python case, we're using Maturin, which is quite funky and I would say maybe a bit delicate. But this orchestrates the correct incantation of invoking cargo with the correct parameters, which gets the build just right, so it can then be exported as a pip artifact and installed into the Python ecosystem properly. And we're having to do this on multi-platforms as well. Most of our developers are using Macs. There's a mix of Intel and Apple Silicon. Yet in production, we're in the cloud, and we tend to be using x86 as well. So we've got a few build targets as well, which complicates matters as well. We have individual builds for those. We are using cross-compilation. For the Java thing, that's actually simpler in a way because we have a standard cargo build which produces a binary, and then that gets wrapped up into a jar using Maven. So we're just using the standard tools for the ecosystem that we're using. So I would say yes, we are sticking with cargo, but I feel your pain.
Okay, thank you.
I think to elaborate on that, I think it depends on the level of sophistication that you're after. In the sense that if you want granular caching or a build system that understands the Rust compilation to the point that it can cache things fine-grained, then yes, like you need to look into something like Bug2 or Bazel. If you're happy to use cargo as a black box, you know, as in I have this process that's going to give me the Rust binary, and then I can kind of encapsulate that into a make file or something simpler, in quotes, then obviously integration is simpler. The problem is that cargo does a lot under the hood. A lot of what it does is not exposed. The famous, build plan feature is planned to be removed. Metadata tells you some stuff, but not all the stuff, and sometimes not the true stuff. And so it's very difficult to kind of peek into the black box, and you kind of feels like you're re-implementing cargo in the other build system, which obviously is complicated and time-consuming.
Yeah, it definitely feels sub-ideal across the board, which is why I was wanting to ask.
One thing I want to add there actually is as well, in our build system, ultimately we're creating Docker containers as well. And we do use Docker layer caching to speed up our builds. Quite often we use the trick where we will have like a dummy library file in Rust, which is literally empty. And we just get the Rust compiler to build all the dependencies. Because they're usually, especially if we're pinning our dependencies, they're pretty static. So that can be cached. And then the Rust build is actually really fast because it's just building our code and the bit of our code that's changed. So there are tricks like that to speed things up.
So I think we can wrap it up with one last question, if any.
So you mentioned data science and artificial intelligence among the organization. Do you have success deploying or even like training models on native Rust stuff like Candle or Lynxa maybe, or at least maybe deploying Rust without Python as a dependency, which is a pain for dependency managing production?
No, we have our machine learning models hosted in a Python container sitting behind an API, and that's how we integrate with them internally. So no, we've not done any integration like that.
I think it's the same story over here. We're still on the data science side. It's very Python world.
So I'll break the consensus. Well, I studied LibFil, so I have a biased opinion on that. And we, as Mainmatter, have also assisted a client in building a very large, pre-processing pipeline in Rust. We're talking trillions of tokens of text to be crunched. And the reality is, you can do it. It's totally doable, but you're going off the beaten path. Which, going back to what we were saying before, it means you're going to have less libraries. It means you're going to potentially have to train people. So it only makes sense to do it if you have a reason to do it. One possible reason, as it was the case for this client project that we did with Aleph Alpha, is you have a lot of data. A lot of data means a lot of compute. A lot of compute means a lot of money. Then if you can, shrink the size of the compute fleet by a factor of 10 because you're using something that's more performant, then it makes economical and business sense to train on Rust. If you want to train on Rust just because you have a little model and it's gonna be done probably just as quickly as Python, then you probably want to use Python. But I guess the short answer is it's possible, it's viable, it's not as streamlined as it is in Python. You probably need a good reason to do it. I wish it was simpler, but it still isn't. And with that somber note, I think we can wrap up the panel. Please give a show of hands for all the panelists.